For the next problem, it states that a tennis player hits a ball 3.2 feet above the ground with an initial velocity of 50.9 feet per second. The question is asking how long will it take for the ball to reach its maximum height? And then the second question is what is the maximum height the ball will reach? Going through what is given, they do not give me an ending height, and they also do not give me a time. We are looking for the height when it reaches the maximum, and we are looking for the time that it takes to reach the maximum height. The problem does give me a velocity of 50.9 feet per second, and it also gives me an initial height of the ball, which is 3.2 feet. Remember the equation discussed in the first video was h equals negative 16 t squared plus v sub 0 t plus h sub 0. We don't know the h value, and we also don't know the t value. We do know velocity, which was 50.9, and we do know the starting height, which was 3.2. To find how long it will take the ball to reach its maximum height, we have to plug in values into the formula t is equal to the opposite of b over 2a. We do this because to find the maximum height you need the vertex. This will give us the time it takes to reach the maximum height. And then we'll take this number, plug it into the formula, and find what the actual maximum height is. The opposite of the b value in this case is negative 50.9, and the a value is negative 16. Remember to evaluate the bottom first, so I'd have negative 50.9 over negative 32. And when I evaluate that, I get approximately 1.59 seconds. Okay? So that's the time it takes. So that answers the first question. Now to find the actual maximum height, we're going to take this time and plug it in for t in both locations in that equation. So the height will be negative 16 times 1.59 squared plus 50.9 times 1.59 plus 3.2. I highly encourage you to try typing this in your calculator on your own so that you know if you can do it correctly. When I typed it in, I got h to be about 43.68 feet. So to answer this question, it will take 1.59 seconds for the ball to reach a maximum height of 43.68 feet. This last problem has multiple parts. So the original problem says that a football is kicked into the air with an initial upward velocity of 50 feet per second. So if I want to write an equation, again, the formula, h is equal to negative 16 t squared plus v sub 0 t plus h sub 0. The only piece of information, or two pieces of information it gave me, was the velocity. So v sub 0 is the velocity, 50 feet per second. And it says a football is kicked into the air. This is making the assumption that the football is starting off on the ground. Okay, so that means h sub 0 would be 0. So if I plug this in, the equation I would use for this problem is negative 16 t squared plus 50t plus 0. Now it's not really necessary to write the plus 0. So if we want, we can erase this plus 0 because we don't really need it. If you kept it there, it's not wrong, but it's just not necessary. So part A is asking, what is the height of the ball after 2 seconds? So seconds indicates time, okay? So that means I'm going to be plugging in a t value of 2 into the equation that we came up with. So I'd have h equals negative 16 times 2 squared plus 50 times 2. When that is evaluated, I ended up with h being 36 feet. So after 2 seconds, the football will be 36 feet in the air. Okay. Now for this one, what is the height of the ball? I'm going to change this, and I want you to change it as well. Instead of 4 seconds, I want you to write 3 seconds. Change the 4 seconds to a 3. I repeat, change the 4 seconds to a 3. So here I'll plug in a t value of 3. So h is equal to negative 16 times 3 squared plus 50 times 3. When I solve that, I end up with h being 6 feet. So the height of the ball after 2 seconds was 36 feet, and the height after 3 seconds is 6 feet. So now it's asking when the ball will be 66 feet above the ground. So now I'm looking for t. The key word is when. When will it happen? The ending height, or the height we want to know, is 66 feet. So now we're going to use the same equation and plug in 66 for h and nothing for t because we don't know what t is. Now recall we cannot solve any quadratic equation that's not set equal to 0, so I'd subtract 66 on each side. Since there are no like terms to combine it with, I'd have negative 16t squared plus 50t minus 66. So what I just did, because I was running out of time, was I plugged in everything into the quadratic formula so that we could solve for t. So the opposite of b was negative 50, plugged in b squared minus 4 times a times c all over 2 times a. When I go to plug this in to evaluate my discriminant, I end up with negative 50 plus or minus the square root of negative 1,720